So this is 11.3, part 2. I should probably put that up in the title. But anyways, I'll do that later. Use appropriate statistics to compare data sets. And how can you describe different distributions? A lot of these notes that you're about to uncover are about measures of central tendency. So to compare the different types of distributions, look at the shape, the center, and the spread of distributions. And again, this is something that we're going to talk about tomorrow, which is standard deviation. That's the next set of notes. So that'll be what y'all do in class on Thursday, right? So the standard deviation, the range, and the interquartile range, which you've already talked about, are three measures of spread. The range of the data set is the difference between the min and the max. The interquartile range is the difference between the third quartile and first quartile. And now we start talking about something called a skewed distribution. A skewed distribution is a distribution where the mean is not in the middle. Like a skewed distribution, if you plot it all, actually we have one in your notes that you did the day before. This is skewed. It's actually what we call skewed right, because that's where the tail is. The tail is on the right. Because it's a skewed data set. And you didn't have one that looked normal in here, but that was a skewed data set. Symmetrical distribution has a shape that when reflected across the mean, the display is roughly the same. We also tend to call these normal curves. This one is symmetric or normal. In that the mean and the median are all in the same spot. The mean is equal to the median. That's the big thing. The mean and the median are in the same number and in the same spot. It's more or less symmetrical. It's said to be normal, which is something I'm about to uncover on the next slide. How can you describe different types of distributions? The shape of a distribution can affect the measures of center and spread and determine which measures of center and spread best describe the data. The mean, median, and mode are all about the same in a symmetric distribution. And you can use either one of the three, but normally you would use the mean, what we call standard deviation. So here's your three different types, and you should definitely be drawing these. Guess I need to put a note there. You need to draw these. And you have your different types of skewing. So this one is said to be skewed left because the tail is on the left. Nearly everybody who teaches statistics calls that the tail. I've never seen anybody say anything otherwise. Then you've got your symmetric. You'll notice the mean, the median, and the mode are all there at the same spot. Go back to skewed left. The mean is on the left side, and that's actually the real reason. But, for students, we say the tail. The mean is smaller than both the median and the mode. On a skewed right situation, the mean lies to the right of the median. And that's what it's really about. Notice the mean is to the left, skewed left. The mean is to the right, skewed right. But focus on the tails, and that's how you get the names right. But anyways, that's the three ways data can be arranged. It can be skewed left, symmetric, or skewed right. And there's actually another one. For the life of me, I can't think of what it's called. It's just too early, and I haven't thought about it in a year. All right, what measures of center and spread would you use for the following data set? So you'll notice that this one is a skewed left. All right? If data is skewed, you always use the median. So you should be using the median. Now, I believe that this data has been laid out for me. Let's see, we got 2, 4, 6, 8, 10, 12, 14, 15. So I need to find the middle. I think it's 29. 1, 2, 3, 4, 5, 6, 7 to the left. 1, 2, 3, 4, 5, 6, 7 to the right. There we go. There's your median. 29 is a good number. Now, since it's skewed left, if you think about that, that means that the mean is less than the median, because it's going to be over here somewhere to the left. But the median would be about right here. Be the median. The mean is somewhere over here. I don't know where it is unless I calculate it, but there's the mean. And the mode is probably somewhere farther to the right. It looks to me like the mode is 33. I see 3 of them. And there's the mode. The mode could be by either left or right. It's not what determines anything. It's about the relationship between the mean and the median. Moving forward. What are the better measures of the better measures of center and spread of the following data sets? So what you really want to do is you want to see a histogram. That's what you want. You want to see a histogram to do this. So we're going to put this data into our calculator. We're going to go to Stat. We're going to go to Edit. We don't need a list 2. This is going to be one variable statistics. You guys did this yesterday. I love that. That probably looks really tiny on your cell phones, doesn't it? You know, this is YouTube. You could put it on your 75-inch LCD flat TV if you wanted to. Just go into your parents' living room while they're watching something and throw on my YouTube channel. And think about how nasty of an email they will send me the next day. All right, 61. Now, I am going to go to stat plots. I'll write this out for a second. Second stat plot. My plots are already on. You'll need to turn yours on. And if you'll scroll down to type, you'll see where there's a histogram. You've also got, there's the box and whisker plots right there. It's all there. This is going to be a histogram. All right, so let's write out what I've done so far. To view the histogram, you go to second y equal, which is stat plots. Turn on stat plots. Under type, select the histogram. And it doesn't say histogram. You have to know what a histogram looks like. You do. And you can even change the color if you want. And you'll see where it has like the X list is list 1. And then we're going to do a zoom stat because that's what we do. So zoom 9. Now, what do you call that thing? That thing's got symmetry. There's something missing here, but if I was to overlay a curve on it, I would call it symmetrical. Now, if you just look at your graph, it's fairly symmetrical. Now, I can guarantee you that the median is going to be over here and the mean is going to be somewhere else. The mean's probably going to be a little bit to the left. So let's take a look at that. Let's go to Stat, Calc, one variable statistics. And I feel like the median is going to be bigger than the mean. The median's 58. And the mean is 57.72. The median is 58. They're pretty close. So I would probably go with the mean. There's a reason for that, and it may not be clear to you as to why we would do that, but this thing would be something we could apply properties of the normal curve to. So I would go with the mean on this. This is fairly symmetrical. I would go with the mean. All right, let's take a look at the next one. So stat, edit, clear it out. All right. Now you're going to have to do a zoom 9 every time you change what's in the lists. Okay, this one is not normal. This is not a symmetrical curve. It's not a normal curve. Can you figure out how it's skewed? So there is more data on the left, which means the median is on the left and the mean is on the right. And again, think about a curve. A curve would look something like this. Whoops, that's not how it would look. Mess that one up. It looks something like this. This definitely has a right running tail. We would call this skewed right. And if data is skewed, we use the median. We use what's called the median. Now, actually, I need to go back to the try it here too. I wish I would have done that. I should have. I should have talked about what the center of spread was for that one. So I'm going to spend a little more time on this problem than I intended. For this data, because I get to use the median, 135. So my measure of center is the median, which equals 135. Now, I apologize for this. I want to go back to this first try it because, you know, I skipped over something. It says if the mean, the median, and the mode are all the same, you can use the mean and the standard deviation to describe the center of the spread. And I didn't do that. I just used mean. I forgot the and part. So it shouldn't take me too long to type this in. Longer than you want to spend, I'm sure. Let's see, he goes 55. I think 55 was in there twice. I know there was a 57. It's in there 3 times. All right. $58 twice. 59 3 times. That thing is multimodal, isn't it? I don't know if you noticed that or not, but it's got more than one mode. It's got 57 and 59 as the numbers that occur most often. It's bimodal. It has 2 modes. All right. So anyways, stat, calc, 1 variable statistics. This guy right here, sigma of x, that's your standard deviation, and it's 1.87. So I should be doing mean and standard deviation. That's what I should be using. So sigma of x is your standard deviation. And it was about 1.78, I remember. 1.87. So if I want to talk about this measure of center, what I do is I say it is the mean x bar plus or minus the standard deviation, because that's going to actually represent 68% of the data. 68% of the data is going to be right there. So 57.72 plus or minus 1.68. So if I do 57.72 plus 1.68, I'd have 59.4. If I do 57.72 minus 1.68, I'd have 56.04. And what I've done here is I've written an interval which contains most of the data. Now, I know stuff you don't. It actually contains about 68% of the data. That interval contains about 68% of the data. That's a rule that we're going to talk about tomorrow, the 68, 95, 97 rule. Because we're going to be doing normal curves. Maybe not tomorrow, but it's coming. All right, here comes the normal distribution. A normal distribution can be modeled by a particular bell-shaped curve that is symmetric about the mean. This is called a normal curve. Approximately normal distributions can be found in many real-world situations where the data are symmetric and mostly clustered near the mean. The heights of people in a large group are likely to be normally distributed. That makes sense. And it says, we got a study tip down here. It says, notice that for real-world examples, the data in a normal distribution might not be perfectly normally distributed, but can be modeled by a normal curve. So even on something I did earlier, I said it looked pretty symmetric, and I went ahead and used it. All right, example 3, are the following variables likely to have a normal distribution? The questions, and I should have blanked some of this out, which I will in your notes. So pretend this isn't here. The probability of landing on each of 8 equal parts of a spinner. So what we have here is we've got where somebody has gone ahead and done some things and plotted some points. The data is not normally distributed because each outcome has the same probability of happening. So this is a histogram that somebody has modeled for this, and they've run the experiment numerous times. And I think if this experiment was run enough times, if we ran the experiment maybe 200 to 300 times, what would happen is the histogram would have the frequency count, the number of times an event happens, and the spinner number Now, the reason they're saying it's going to happen the same number of times is because the probability of spinning and landing on any number 1 through 8 is 1 in 8. But over time, we would begin to look like this. And for the life of me, I cannot think of what this is called, and it makes me feel kind of stupid. But I just can't remember what we call this guy. It's a particular curve that's not called a box. It's not called constant. It has a name. That's bugging me a little bit. But that is nothing. Like, we're not going to do anything. So anyways, second one is the scores on an easy test. So this is more or less true. I've been a teacher for a long time. And I can tell you that if you give an easy test, the majority of kids will be close to average. So that is what this histogram is. Now, they are skewed left, but not normal. More students get a higher score, but still not going to be able to do this. Now, let me ask you another question. What do you think the distribution of scores on a hard test looks like? So if you give a hard test, what's going to happen is the majority of your kids are going to be over here, close to the 0, as opposed to 100. So if we did a frequency count, if I talk about last year's group, there would have been a whole bunch from like 0 to 10. And it would really peak somewhere probably around the 30 or 40 range. And then it would start falling off dramatically. That's what a hard test would look like. We try to do it, believe it or not an easy test or hard test, something in the middle. All right, so recognize a normal distribution. Are the following variables likely to have a normal distribution? The heights of all the people in a large group. Yes. Heights are considered to be normally distributed. Yes, in a large group. In a small group, probably not. Test grades on any given math test for a small group of students. No, never. Tests are usually skewed right. They usually are. Test grades on any math test for a large group of students. Still no, never. It's math. No, never. I wish we could, but it's not the way it is in mathematics. All right, recognize normal distribution. Are the following variables likely to have a normal distribution? The number of children in a family. Your notes have this histogram blocked out, but if you actually drew a histogram for the number of children in a family, you would find that the frequency of having 0 children is fairly high, and then 1, 2, and 3, and it drops off significantly. Because like this is over here, this is like, Mormon territory, right? 10 kids? That's crazy. Who would do that? All right. In each situation likely to be normally distributed, explain the weight of individuals in a population. Okay, so the weight of individuals in a population. So there's the first one. We have the low end of the scale here. If we include children and such, that's one thing, but let's say we've got 20 pounds, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, and then just so forth. If you talk about a large number of people, which is what they're talking about, a population, you're going to find that the majority of the people are somewhere in the middle. Of course, America's getting fatter every year, but the majority of people are going to be in this vicinity right here. That's where they're going to be. And then it's going to start tailing off evenly. Now, this is like the children's home, and this is like the really obese people. But yes, population the weight is going to be normal. Scores on a difficult test. So we talk about the test one. If you talk about scores on a difficult test, the truth is the majority of kids are going to fail that test. This would be the 60, and this would be the 100. And the vast majority of kids are going to be over here. And then it's going to taper off. Not a whole lot are going to pass. Very few are going to make a C. Very few are going to make a B. There might be 2 or 3 A's. So a hard test is always going to be skewed right. That's just the way it is. Doesn't matter if it's math or English. A hard test is always going to be skewed right. An easy test is always skewed left. All right, we're almost done with these set of notes. How would you classify the following data set? Describe the shape of the distribution and the center of spread of the data. So they want us to make a histogram. I don't want to do that by hand. I'm not going to ask you to do that by hand. I probably should, but the calculator does such a good job of it, I'm not going to spend time on it. I am going to put all my data into list 1, and I'm going to let this technology do it for me. So I was looking at the time here, and hopefully some of y'all are waking up for school. It is 6:39. I have a hunch, though, you're teenagers. I remember being a teenager, man. You'd sleep in until the last minute possible. You drive way too fast to get to school. Hope you didn't see a state trooper. Of course, I lived in Palmersville, and they loved Highway 89 back when I was a kid, especially when they knew, like they know when school starts. So they would be out there during those last few minutes trying to catch those kids who are being lazy and sleeping in. And they'd get you because that's their job. And believe it or not, we need troopers to be like that to teenagers. Because teenagers need to learn how to drive, need to learn how to slow down. All right, so we go to stat, we go to calc, one variable statistics. I don't know why, probably because I just wanted some stuff. You can actually look at the one variable statistics and figure some stuff out. See, there's X bar, it's about 97. That's the mean. The median is 98. Now, that's all I have. As close as those are, I think it's going to be fairly normal looking. I could easily be wrong. It's not that hard to create data that's skewed and then it doesn't appear it. But I'm going to go with that it's fairly normal. So let's do a zoom 9 because I've already turned the histogram on. I don't know if that's normal or not, but it kind of is. It's a funny looking one, isn't it? I don't like that one at all. But I'm going to have to call it normal, as much as I don't want to. It's the best pick. It's not skewed left. It's not skewed right. The best pick here is normal. So, the best pick is normal. All right, analyze the shape. We've done that. Step 3 says determine the center and spread of the data. Use the median. Well, they're saying it's skewed. I don't agree with that. Don't agree with that at all. I guess it is skewed, isn't it? Nah, let's go with your textbook. It was written by somebody smarter than me. Stat, calc, one variable statistics. So I've got a mean of 98. And what was my mean? Man, these are so close. This is normal. I'm sticking with it. This is normal. I don't buy that. So X bar, according to my calculator, is 97.07. And X bar is your mean. Okay, that's why I'm using it. Standard deviation. I'm tired. Standard deviation, which your calculator calls sigma of X, is 18.06. Now, our measure of center is X bar plus or minus the standard deviation. And let's go ahead and compare that to what the author of the book is suggesting we do, okay? Because it's not bad practice. I don't know what's up with my calculator today. 97.07 plus 18.06 is 115.3 at the top end. Notice I'm using interval notation too. I'm sure you love that. And if we take away the 18.06, we get 79.01. Now, if we do measure of center to be the IQR, the interquartile range, which is quartile 1 through quartile 3, quartile 1 is 76, and quartile 3 is 115. I don't believe that either one of these is honestly a bad pick because of how close they are. But I still feel by looking at that graph that that should be a normal distribution. I don't know that it should be skewed because I can kind of see some symmetry. That's the big thing, is symmetry, and it does have symmetry. Anyways, there's a question I don't like. And that's going to be the last one I do, even though I probably should do another one, but I'm sure you're tired of watching this video. So thank you for watching.